Welcome to the webinar of how to identify groups and predict outcomes with IBM SPSS DecisionTrees. IBM SPSS DecisionTrees is an Azure module which contributes to uncovering relationships between variables and to grouping individuals together. It uses segmentation, profiling, and prediction. These terms can be explained as follows. Segmentation is a process of grouping individuals based on their characteristics. Profiling is recording individuals' common characteristics. And prediction is estimating a future event on the basis of historical information. The example application that we are going to see today is about customer retention. The questions that we will answer today is whether the customer stayed with the company or not, and which are the key drivers that have influenced this decision. The two possible answers are yes or no. So what are the profiles of customers who stayed with the company, and what are the profiles of customers who churned? If we determine the characteristics of churners, we can then customize our retention strategies for each specific group or segment of customers. We can now proceed to a demonstration of how you can identify groups and predict outcomes with IBM SPSS DecisionTrees. Firstly, we can have a look at the data. Each row represents a customer and each column represents a variable of information. The dataset contains some demographic information such as age, income, and education. And we have some additional information such as the number of years that they have been customers of the company, the number of products that they have purchased, and whether they are churners or not. We could run many crosstabs to check whether there is a relationship between different pairs of categorical variables. However, we will not be able to see how the variables interact with each other in total. For this purpose, we could use decision trees. If we select Analyze, Classify, and Tree, the dialog box for decision trees comes up. What we want to do is to profile the customers based on whether they stayed with the company or not. This will constitute our dependent variable. By running a decision tree, we will then be able to find out which independent variables affect whether the customer stayed with the company or not. So in that case, we drag customer retention in the dependent variable box, and we click on categories and select no, as this is the category that we are interested in. If we click here continue, we can now drag the rest of the variables to the independent variables box. There are 4 different growing methods that we could select for our decision tree. In our case, we will select CHAID, which stands for High Squared Automatic Interaction Detection. This method is running in the background crosstabs for the dependent variable against the independent variables and is breaking them down by which is the most statistically significant variable. In the output section, we can select to plot a gains chart and we can click here continue. And we can just go to the save options now and we will select to save the terminal node number and the predicted value. And we will save our model in an XML file as well, so that we can apply the model quickly on any future similar data set. So we just want to save our XML model on our desktop, and we could give the name Decision Trees. Click Save, and we can now click here Continue. If we click OK, we can now see our results from the decision tree procedure. The first table summarizes the properties of the decision tree and which variables were finally selected in the model. In our case, the income level, the years of the company, and the aids are the independent variables that were included in the model. If we scroll down, we can see the actual decision tree. If we double click on it, we can now have a closer look. The first node is simple frequencies of who stayed with the company and who did not. We can see that 41.4% of the customer base are turners, whilst 58.6% are current customers. Using the change method, income level is the best predictor of customer retention, as it is the first most important variable that the tree indicates. For the customers that have a low income, the next most important predictor of customer retention is for how long have they been with the company. 90.1% of the customers that have been with the company for less than 5 years and have a low income have not stayed with the company. This number is already giving us some information that the company has to create a special retention strategy for this specific group of customers, as there is a high churn rate. The decision tree breaks down to the age of customers. If the customer is less or 35.4 years old, then the percentage of churners increases even more, reaching 94.5%. If the customer is older than 35.4 years old, the majority of customers still did not stay with the company, but this percentage is lower than the one of the group of younger people. If the customer has been with the company for 5 or more years, even though they have a low income, the majority of customers have stayed with the company, as 61.6% belongs to the category of yes. For customers that have a low or medium income, we can see that the tree breaks down to the same variables: years with the company and age. We can see that the churn rate is 80.8% for customers that have a low or medium income, have been less than 5 years with the company, and are 28 years old or younger. Hence, this constitutes another profile of customers which should draw the attention of the company and raise the need of a tailored retention strategy. The terminal nodes all constitute different profiles of the customers, each of them defined by different characteristics. The next results we are going to comment on are the risk and classification tables. These two tables judge the performance of the model. The risk estimate is 0.189, which indicates that the model predicts the customer retention incorrectly 18.9% of the cases. This is verified by the classification table, which gives an overall percentage of 81.1% for correct classifications by the model. We can see that the model does a better job for the prediction of the yes category, as 88.9% are correctly predicted, whereas only 70% are correctly predicted for the no category. The gains chart is another way of looking at the power of the model. The model is compared against random. The diagonal line represents a random model, and the other curve is for the category no of customer retention when we apply our model. The greater is the distance of the curve from the diagonal, the more we expect to gain. For example, if we would randomly select 50% of the customers, we would be able to capture 50% of the customers that have not stayed with the company. If we apply the DecisionTrees model to our data, we expect, for instance, for the same percentage of the overall population to capture around 80% of the churners. If we go now back to our data, we can see the two new variables that were created. The terminal node number refers to the different segments within our customer base. It constitutes very useful information, as we already found out some of the segments that require a special retention strategy. We could easily select out the customers that belong to these segments and have a list which requires special retention strategy ready within seconds. The last thing we are going to look at today is how to apply the model we saved in an XML file on another dataset. Let's assume that the company has a new dataset of new customers that contains the same information as before, and what they want to do is to be able to predict whether these new customers are going to churn or not. In that case, what they can do is that they can use the model that we built before. So if we go to Utilities, Scoring Wizard, and we browse for the desired file, which in our case is saved on our desktop and it's called DecisionTrees. We can select it, and here is where we can see that the target is customer retention and the predictors of this model were age, income and years. If we click Next, this is where we can see the matching model fields to the dataset. So the model fields are age, income and years, and the matching dataset fields are the same. If we click Next, here is where we can specify what we want to save. So if we want to create new fields in the dataset, that will indicate to us the probability of the predicted category, the probability of the selected category, the predicted value, the node number and the confidence. The probability of the selected category, here is where we have to specify the value, and if we click here Next and Finish, we can see that the new dataset has been scored. So for example, for the first new customer, we can see that the customer is predicted to be a churner. The probability is 0.57 and it belongs to the segment 14. DecisionTrees is a technique that is commonly used in database marketing, where you can target customers who are more likely to respond to a marketing campaign, in market research, where you can uncover which are the key drivers for customer satisfaction, in credit risk scoring, where you can predict which customers are more likely to default on a loan, and in the public sector, where you can, for example, identify the optimal allocation for local government resources. IBM SPSS DecisionTrees is an easy-to-use and powerful application. It helps you identify groups and patterns quickly and visually, and it can be understood by a non-technical audience. The option of saving the model in an XML format saves time in case the user wants to rerun the model on a new similar dataset. IBM SPSS DecisionTrees is an add-on module for IBM SPSS Statistics 20. IBM SPSS Statistics is a modular system. There are 14 add-on modules which add extra functionality to IBM SPSS Statistics base. IBM SPSS DecisionTrees is one of these add-on modules. Please contact us for further information, either by sending us an email or by calling the phone number that you can see on your screens.